Hi, this is Professor Kim Nelson with the Jewelry Design Department at FIT, continuing our series of videos for basic CAD modeling, working with Rhino 3D class. I'm continuing on with the band ring. For those of you curious, yes, I liked it a little wider, so I redid it. This is the redone version. It'll look the same to you at home, but it is exactly 2% wider and nicer because of it. Alright, so what we have to talk about now is how to Boolean, because as I discussed in class, this piece, I'm not done with it even when I Boolean it, but there are things I want to do further with this, like I said. But for your rings, in order to print them, in order to work with them beyond this point, they have to be Booleaned into a solid object. And that's what Booleaning does. Booleaning takes two solids and creates a third solid from them. Okay? Generally destroying the parents in the process. So, to give you an example of how it works quickly, like I did in class, I'll make some spheres. Two spheres. I'll make this one a little smaller, just so you're not bored. Okay. We have three varieties of Booleaning. Intersect. Actually, you have union. And it works best if, first off, if there are two different layer colors in play, so you can see the difference. And in wireframe, so you can see that we do have an overlapping of geometry. For the purposes of making this easier to see, I'm going to change the properties of these two spheres. There should be a place here, oh, it's not selected, where I can just change its isoparm density. That's how many wires it displays itself with. I'll go up to a level of 5. I'll do the same thing here. It doesn't change the object at all. It just makes it easier to visualize in a situation like this. So if I do Boolean union, solid union, select the surfaces you want to union. Which layer or color they'll end up on depends on which one you pick first. Enter when done. And you'll see that Boolean union removed all of the surplus geometry inside, leaving you with a single shell. And that is what you need to have when you print your parts, a single unconvoluted, unself-intersecting shell. So that's union. The next one we have is intersection. Intersection, you pick the first set or surface or polysurface. Enter when done. Select the second one you're going to intersect with, and Rhino makes a third new, or replaces them with a new solid object. That's key, by the way, that when you do a Boolean, you end up with a solid. Okay? The last one is subtract, or difference. Select what you want to subtract from, hit enter. Select what you want to subtract with, hit enter. And you can see that it's cut away. Once again, leaving behind a single shell. What happens if we don't Boolean? Are there other options? Yes, there are. For years, sadly, because I didn't know any better, I actually did this as a standard way of making a shell. You can actually trim them with each other. You can do that a couple of ways. One, you can just select one as a trim tool. Trim. That one. And then trim. Let's say we want to do a union with that one, and then join the two together. If you're lucky, it'll go solid. One closed surface, one single shell. And of course that will work just as well for intersection or union. shell-free intersection. Okay, so it is you can do it by hand. It's hand stitching. If your forms are complicated and they don't want to trim off each other, which is usually the case, you can create an intersection curve. Select your two objects, click Object Intersection on your Curves from Objects pop out. Okay. That'll create a curve object, curve geometry. Then you can use the curve to do the same. Throw away the curve, join them together, same end result. Okay, but Boolean is much faster. It supposedly, I mean, it comes close to guaranteeing a solid object, and you can do several parts at once. So if you have several things you're going to Boolean, you can do them all at one time, whereas hand stitching is one item at a time. Okay, so that brief introduction done, I'm going to Boolean my parts. You always want to Boolean flat. Okay, so you will begin with your flat parts. Now they're already in position for your flow. Everything should be good with them. All that needs to be done is that they need to be Booleaned. I'm going to ungroup, hit Control-Shift-G as many times as I have to until nothing is happening. Okay. Now, I have a few options here. The obvious one is to do this with one motif and then copy it around. So that's what I'll do. It helps if things are in a few colors so you can tell when the Boolean is working. So now in theory I could just go at it and Boolean, Boolean, Boolean. Challenge I've got though is my wires form loops with self-intersecting geometry. We talked about that in class. Okay? So I've got to be careful what I do next. Self-intersections always warrant caution. Trying to get down to where I just have this layer to look at. Okay, so if I Boolean this right now, it's likely going to fail because I have a coincidental surface with those two caps. You can see cap there, cap there, cap there, cap there. And if I remove the caps, which I'll do right now, extracted those surfaces, delete them. Wireframe, you can see I no longer have the plug in the middle of the drain. So, in theory, I can now join these together. Flash, it's happy, it's solid, we think it's good, except for we happen to know it has self-intersecting geometry, which we can't work with, okay? So, that's what would happen if I tried to go that route. I'm going to try and Boolean them and see if it works. But I've got to be aware of what happens here if it does work. So at these intersections where we have the coincidental surface. Solid union. It worked. Now my question is, what did Rhino do here? Do you see that? It left the plug in the drain. This part won't print. I'm okay with that for now. I'm going to just keep going. Yeah, got the plug in the drain here. Same thing. Okay. And I still have self-intersecting geometry that I have to resolve. So Here goes. See how helpful Rhino is? It made me a Boolean object. Everything's perfect. Except for no more self-intersecting geometry, but I've got plugs everywhere. So I'm going to remove those. Anywhere I see them, drag a window around them, as long as I'm in the extract surface command. And delete them. Now the problem is Rhino doesn't show anything wrong with this unless I turn on naked edges. And you'll see you have naked edges through here appearing because Rhino didn't build this object, didn't Boolean on it with the assumption I was going to pull those out. So rather than worry about tidying that up, I'm just going to extract surfaces. Extract that one. Extract, extract, extract. I could have exploded it just as effectively. And I'm going to join it back together again. Turn on my edges so I can see what I've got. See? It didn't leave an edge naked that time. Join. See? No edges naked where it's joined. Join. And flash. Now it's a solid. No self-intersecting geometry. Okay? This is the problem I face with each one of my patterns. So I'll take care of the next one with less conversation, of course. Not sure where all those curves are coming from. Okay. Apparently, somewhere along the way, I changed the layer of my master curves here to blue. It's a good thing I didn't delete those. I was just about to hit delete. I would have been a very sorry customer. Okay. Always good to check. Alright, so I have the same situation. Exactly. I am going to change these to another layer so I can see what's happening and start my Booleans. I will not be surprised if at any point the Boolean fails, because I have coincident. There we go. Boolean union failed. Thank you, Rhino. And that means it'll fail here too. Yeah. Rhino doesn't like these coincidental surfaces. Other one, it was fine. These it does not like. Okay. So that's actually helpful in a way. At least it shows you that it fails based on that. So I'm going to go ahead and remove those. Before I do, though, I have a problem I need to solve. I need to be able to Boolean these two pieces without having any of these caps in my way. So first I'll remove the caps. Delete them. Join my part together, just to test for fit. Fit is good. It's a solid object with all kinds of self-intersecting surfaces, which I now need to break down. Undo join. Okay, so I need to split this anywhere along this main area here. What I don't want to do is, ideally, I don't want it to be in a really tightly kinked area. In my particular design here, I don't have a lot of choice. So, somewhere in here, I will split this. And then I will cap these two pieces. And I will union those two pieces. extract those two caps. And join this piece on. Okay. I have the same situation here. I need to join this to this. I can't have the self-intersection at the end. So I will remove the cap. I will split this the same way I did the other one. Anywhere along here. Split this. Okay. Cap planar holes on these two. And Boolean union. Because now I don't have any coincidental surfaces where these two meet. See? No self-intersecting, no coincidental. Extract surfaces for these caps. Join this little loop on, which I now can because there are no plugs in the drain. And there we go. Remove that curve. Okay. So the last piece I have to worry about is here. Okay. So I know I can't have this cap in place. I'm not sure I still have a cap in here. Yes, I do. I have one right there. So I've removed my caps that can get in my way. I'm going to split this right here, as I've been doing. So now I have this and this. But that's not going to be enough because once I cap these to make them solid so I can Boolean, I'm going to have coincidental surfaces right here. So I need to do the same thing over here. Split this with that curve. And now I'm good. Cap planar holes on these two. There is no coincidental surfaces where the caps touch, so I'm good. Solid union. Remove caps. So yeah, I make caps, remove them. Make caps, remove them, depending on what I need. Join, join. It's a solid object with no self-intersecting, all one shell, and no plugs in the drain. No caps stuck in the middle of my pipe. Okay, it's good. I'm going to Boolean it to the one I just finished and hope for the best. Solid union. Okay. Now, since neither one of those had a problem to begin with, the combination of the two should also have no problem. That's important. What I just said, I'm going to repeat it, because both of those two original parts had no problems with them. No self-intersections, no coincidental caps. The combined object I make from the two shouldn't have any problems. Okay? If I had left the problems in the other two, clogs in the drain, self-intersections, but I'd Booleaned them and Rhino said it was fine. When I put the two of them together, I would just multiply the problems. And at some point, Rhino will catch on and it'll refuse to Boolean. And you'll go, okay, what's wrong? And you'll look on the inside of your part and you'll see that you've got tons of this stuff going on and it's overwhelming. You think, I just got to start over. You know, you'll be very upset. So now I have made a critical error, which I will share with all of you. I've been Booleaning, showing you what's going on, without making a copy of my Boolean curves, my unboolean curves, in case I want to undo any of this. Let's see if Rhino will forgive me. Undo, 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 undo. I'm looking to go all the way back. very beginning. I only need one. Although, why not keep them all? There. Control C, copy to clipboard. Those are safe. Now redo. Nothing to redo. Control V. There are my original curves, intact. I'm going to move them up and out of the way so I have them someplace safe. Turn them off. Now back to work. Solid union. Take a look at these red pipes. See what I'm facing. This is the steps that you take. You check each component as you go to see what's in it. No self-intersections, but good clean intersections. These should Boolean nicely. There shouldn't have any problem here. Solid union. Solid union. Solid union. Union failed. Now that's interesting. There's nothing here complicated enough to make a union fail. So I'll try doing them all at once. Sometimes it's crazy, but union failed. Okay. So I'll union what I can. Okay, it's not going to take it. Okay, how about you guys? You guys? So those will union, but these two won't. Now I'll go into where the problem is. I'll try trimming with surfaces first. I know it won't work, but I try, because it'd be easy if it did. No. When Rhino says no, it begins to become a problem. No. Okay? I'm not surprised things like this happen all the time. Intersection. And there you see the problem. Are either one of those a closed curve? They're not. And a closed curve is what is needed to trim. So how far off we are, I don't know. But I'm going to do a blend curve, just a quick blend between these two. And then I'm going to join them. It's closed now. And I'll see if that curve will trim off what I need. No. I'll explode this surface, poly surface, and see if this curve will trim off what I need. Trim off the wrong side. Yes. Well, leaves a corner. Yes. Okay. Let's see if it'll trim off the portion of the green that I need. Nope. I have to explode that too. Grab my curve, trim. This means that the math somewhere is so barely off. It's important to pick the right part. You don't want to take away what you need to have left behind. Okay, we're done there. single shell, and hopefully that'll join up nicely. Okay, coming over here, our open curve, blend curves, join. Now we have a closed curve, and trim what we need to remove. No. Bad. Okay. Repeat the trim command. Take away what we need to remove. Delete. There seemed to be a lot more taken out over here, which makes me suspect I missed something over here. Yeah, I think I may have done. Notice how I'm dragging and I can't get what I want, and oh, my camera's all messed up. Select where you want to look. Select some geometry. Set view. Zoom selected. Recenters your camera on your model. Actually, that looks okay. So let's join it and see what we end up with. Join, 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 join. We have a naked edge right here that Reiner didn't like, right where I had done that blend curve. I'm expecting that. So, join, 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 join. Okay, and join. The color for joining is the same as for Boolean. The thing you pick first determines the finished color. A few pieces left. It's still an open poly surface. We have those naked edges. Let's go take a look at them. Right where those curves were at. So, analyze edge tools. Join two naked edges. Looks good. Looks good. To make sure it worked, I'm going to extract one surface somewhere away from where I made the repair. I'm going to join it back together, and it should flash and go dark and say it's a solid. Closed poly surface. Closed. Solid. Excellent. So since there are no problems in this geometry, and there's no problems in this geometry, except for I've got some unhappiness here, but it's a maquette, so I'm okay with that. Solid union. Now, if your models, if you're not going to plan on doing more work, you would need to go in and fix that. And there we go. Okay. Now there are ways I could fix this that would not require me to go back and undo everything. I can actually take out these little surfaces. Not you. You. And if they're in one place, they're in another. And then I can delete those. Now I have holes in my model. Okay. I can go back and select the surfaces that have the problem. Extract them. Now I'm going to extract and make a copy. Copy equals yes. So the original surface is still there. I'm going to come in here and edit tools, surface, edit tool, untrim, it didn't keep my border, so I don't like that. Surface, Edit Tools, Detach Trim. Select the edge to untrim, and there you have it. So on this surface, you have the curve that cut it, and then the original surface. I told you Rhino keeps it. Oh, we still have some trimming over here. Okay, so we're going to have a bunch of curves. Kind of in the same place, so I remove those. So here's the curve that cut it originally. I'm going to explode that curve. Take out the parts that make the hole. The holes. Also, any little tiny bits that are just kind of ugly, get rid of those. Join what's left. Throw away the bits and pieces. Interesting. Okay, so we have that. We have the pieces at the end. I'm going to hide this. I told you, when you do what I just did, you get lots of copies of the surfaces, of the curves. Many more than you want. Explode. This is all I want. Curve, extend curve, or actually blend curve. Quick blend curve. Throw that little piece away. Quick blend curve. Join these together. Unhide the surface. Take my curve and trim. Delete the curve, delete the curve. This is going to replace this surface. So, extract surface, copy equals no. That's the one because it has the notches we don't want. Uh-oh, I made a mistake. These two notches over here were important. Tricky because there are lots of pieces, lots of copies to deal with. These are the two we don't want. I'll get rid of that while I'm at it. There's a copy of that curve. Okay, blend curve. Join these together. This curve isn't necessary. Any of them. And trim. Are you getting a sense of, I mean, you can go in and perfect things. The question is, what way is the fastest to handle it? Okay? Okay, when I put that back in, this will repair this portion. And then I can repair that portion, and I can do the same thing over there, okay? We don't have time to go through the whole process for everything. But I wanted to show you what the strategy would be. I have this. Okay, bringing in my sides, going to Boolean union those. I shouldn't have a problem. There's no self-intersecting. This will hopefully go smooth. Yeah. So that is good. Turn on my pattern. Actually, mistake. Before I Boolean those two together, with my pattern I have to mirror this. Across the point. have to rotate this with a copy option. Around the same point. There we go. Now I can union. I already know this one takes a while. Let's see if this one does. So far, so good. Do these two Boolean together nicely. Yes, they do. Cutting plane. But not yet. Transform copy. Point. Point. Do these two union. Yes, they do. Okay. So the last thing I need to worry about is trimming off the end here. Cutting plane. At the end of my curve. Analyze direction. Flip it towards what I want to keep. Copy that out to clipboard. Solid difference. Delete input equals no, so that surface stays behind. Paste back in. Flip the direction on that surface. So when I Boolean on this time, it'll only leave behind the end. Difference. This time delete the input, so the surface goes away. Move this into position using my point snap on my layout grid. Boolean union. And it works. So now my flat layout, guys, has no self-intersecting surfaces, no plugs in the drain, no naked edges. It's all solid and good. And that's what I will flow. Because once you float into three-dimensional space, all of these problems become more complicated. Okay? A 3D arcing form, figuring out how to trim and attach and stitch and Boolean, it gets a lot more sophisticated and complicated once it's up in the air. So, but now I can transform flow along curve. Sorry. Oops. Sorry. Along curve. What I did wrong there, when I go oops and I just fix it, you may all wonder what I just did wrong, so I'll do it again. I didn't pre-select the geometry, so I hit flow and I wasn't reading my command line. I just picked the object, the curves I wanted to flow along. And I thought, how come nothing's happening? Well, it's because it's still waiting for me to pick what I want to flow. If I hit enter right now, it thinks I want to flow these two things, which I don't. I want to flow this. So if I was reading my command line, I would have gone, oh, I forgot to pre-select. That's what I want to flow. This is my first curve. This is my second curve. Now you'll notice I'm not using history. I'm not using history because these should already go exactly where I want them. I've already tested it. It should already be good. And it is. Okay? The last thing I would want to do is prepare my rims. I want to fillet the edge of my rims. I'll fillet them 0.5 millimeter. Let's see what that looks like. Type in 0.5 first. Select my rim edges and take a look. That's pretty subtle. I can go a little bolder. 0.6. Then pick my edges. Yeah, I like that. Notice history's on, so it did both of them. Comfort fit my band. It's nice. Bring back my pattern. That's good. And once again, before I Boolean, Control C, copy it out, Control V, paste it back in, Control G, group it, and then store it somewhere. I'll hide it for now. But that way I have a copy of it in my file unbooleaned. Solid union. Those three parts. Enter. And I'm good. I go wireframe. Everything is a single contiguous shell. And that's it, guys. That's how I would boolean and finish my ring to print. Thanks for watching.